The first video I ever posted on my YouTube channel was me making a 3D renderer from scratch, and it actually did pretty well. And I really wanted to expand on this, so I made a 3D game from scratch. And in the process, I learned so much more about 3D rendering, and I optimized a whole lot and really just made something that I think is really cool. Whenever I made the 3D renderer, I just threw everything into one file. And I didn't really like that. So I first separated everything into its own separate file. I added some other basic reworks, but there were a couple of major problems with the current 3D renderer. Whenever I made it, I cut a lot of corners that I didn't realize that I had done. The first major one is that I drew triangles directly to the screen using a built-in library. Now this allowed me to not have any depth, because I was just drawing one triangle and then another. So anytime I wanted to render two triangles, I would have to render one and then the other triangle. And this is kind of good at the start, because you see we can just render this triangle over this triangle if it is first. However, there are a couple of edge cases. First of all, the method that I used to render the triangles on top of one another was imperfect. If you watched the last video, you could see that I had some glitches with the layering of the triangles, but the main problem is actually intersecting triangles. So let's say I have this triangle right here, and then there's going to be a triangle that goes through it. I can't make this my program, which just draws flat out triangles, to be able to draw this without like dissecting the triangles, which is some really complicated math. Yes, I could make it work, but that would be very complicated, not stuff that I want to be doing. It is possible, but there is a much better way that will allow me to implement a whole lot more function into my 3D game. I was going to do something called triangle rasterization, which is whenever you take the 3 points and project it onto a pixelated surface. So we are converting our game into basically a buffer of pixels which we write to, and then we convert the pixels into an image. Now to actually rasterize the triangles, there are a couple of methods that I had to go through until I found one that worked. So one method, it takes the 3 points and it's going to divide it into multiple triangles. I'm going to move this point down here to better illustrate this. So whenever you have a triangle, it is a lot easier to rasterize these two triangles than to rasterize this triangle as an entirety, because you can use this base and just keep on going down and they will go down to the same y value, which simplifies things a little bit. However, I had trouble with this approach and I got a lot of infinities and undefined values, because whenever you have like straight lines and stuff, I just didn't write the code properly, and there were a whole lot of better ways that I could have implemented it, which I eventually did. But there is one way that I did consider, and that is whenever you start at the top and work your way down on both sides until you get to the bottom line. Now obviously there's some edge cases here, but that is basically how it works. And then for all of these, there ends up being a function where you draw a line, usually horizontally. That's pretty simple. For this function in particular, these lines that we're drawing right here are actually referenced in my code. They're called a Bressenham line, and I actually implemented a sufficient function which draws Bressenham lines, which actually allows me to draw the borders of items. Obviously you can see that I commented out the code that draws the borders for the triangles, but this does work, and if I wanted to implement it further, I could make it to where I could draw the borders of squares and whatever other shapes that I currently have in my renderer. But at the end of the day, the implementation that I actually went with was much simpler. You basically take the points of the triangle and you draw a square around them, or rectangle. And what you're going to do is you're going to go through every point in the square, which is really simple because we're on pixels. So you go through every pixel, and if it intersects, you draw the pixel, otherwise you don't. So very simple. And now this brings me to my pixel class, which ended up getting very complicated. All you need to know right now is that it holds depth and color. So we initialize it with a background color, and then as we render the triangles, we're going to add color to it. And now it gets into a lot more complicated stuff. That way I could add some really cool effects, but we'll get into that later. However, the big thing for both the drawing brush hand line and the triangle rasterization is that it allows me to interpolate the Z values, which allows the pixels to be properly layered, and even if the triangles are intersecting, because we're drawing this pixel by pixel, so everything should theoretically work out fine. And although this gave me a lot of trouble, I eventually did get it working. Now, once I got this working, I actually ran into a lot of trouble with clipping, which was surprising because in the original 3D renderer, this was actually not a problem. However, I eventually realized that, yeah, in my original 3D renderer, it wasn't a problem because the function worked perfectly fine. I'm not entirely sure if it's optimized, but it's optimized enough for a 3D game. So I took this function that I already written and I just added it to what I already had, and it worked perfectly. It clipped the triangles based on the camera and allowed for no lag, no bugs. The triangles will actually draw upside down sometimes if they're behind the screen. The clips get really wacky. Hopefully you're going to be seeing some of them right now. And so I added a camera function, which actually ended up being really simple. I add the camera, the transform, the rotate, and a normalized vector, which we'll go into later. That's a bit of me cutting corners, but we add the camera, and the camera, it makes everything feel a little bit better. You know, like I have more control over the game. And this was in the initial state where I was trying to keep my code clean. So we do have a camera class, and I added some basic movement to it in the renderer function, where we can move it any which way, and everything appeared to be working well. However, there was one problem. Whenever I was testing this program, I actually had the screen that I was testing it on minimized. Like, I didn't need a big screen, so I just kept it the way it is. It was like 800 by 600. But whenever I was actually writing the FPS, I realized that it was crashing the moment I went full screen. And I didn't do this until a while into the project, and that was a big problem. Whenever the screen was only a couple pixels tall by a couple of pixels high, there were like 100 pixels, the game was working amazingly well. Like, the frame rate was up in the 60s, and then I went to the 800, 600, and it dropped a little, but it was still good. But whenever I went to full screen, the game completely crashed, down to 0, 1 frame rate. It wasn't even loading for me sometimes, and so I knew that I had to fix this, because a game that can't be full screen, what's the point in that? So in the render function, I added this very important quality saver, which should be called the game saver, because this saved the entire project. Quality saver is passed into the screen, and whenever we go to the screen class, we can see what it actually does. We take in the inequality, and it divides the height and width by that. So wouldn't that make the image drawn to the screen be only like part of what we see? So if we have the screen like this, then if we have everything, this is going to start in the top left. That's how most things work in code. Isn't it only going to draw this little corner? And you would be right, but there is a really cool thing that we can do where whenever we draw the image, which is made up of the buffers, we can actually change the height of the image. So it's basically a cheat code. I could have implemented this manually, but the g.draw image makes this really simple. I just multiply the width by the quality and the height by the quality. And so basically every pixel on the screen, rather than being rendered individually, it's going to be projected to be 4 times as big. And now, whenever you use a quality saver of 2, this is really hard to notice, but it improves the performance immensely. I go from 0 frame rate all the way up to like 60 sometimes. And so it's pretty cool. And you can even increase the quality saver to some pretty wacky values. It's actually kind of fun to play with it. Like if you increase it to 100, you're gonna see only a couple of pixels on the screen. But regardless, this is the way that I saved the project from just not working at all. So now that I fixed all the flaws on my 3D renderer, I could finally start working on the game. So the game was going to be a runner. I really wanted it to be simple as possible. As you will see, it ended up being a little bit more complicated than simple. So the game that I had planned was going to be a little bit like Run. So you had these tiles, and this would be you. Obviously this is all in 3D. And the tiles would be moving backwards, and they would spawn randomly. And you would have to jump from one to the other. And this could go in multiple directions. So I'm going to try to draw 3D real quick. You could have like not all the tiles be there. So this could be void and this could be void. And you just got to avoid the holes. And so that was going to be the runner. And now since the Y value for all of the ground tiles was going to be simple, I was able to add really easy gravity and really easy movement. A little issue that I had was going through every single square, which I only went through the squares because I knew I wasn't going to implement any other shapes that I need to detect as a platform, and I didn't want it to break anything else. And so I would detect if the square was intersecting the square of my player, and if for every single square it wasn't intersecting the square that I had, I would let the player fall, and eventually I would add resetting, but I actually didn't implement that until way later. What I actually made was really buggy, and honestly it kind of still is, but it does what it needs to do. And now this is where I started cutting corners. You see, now the game that I was going to make was actually going to have the floor tiles move and the player would stay still, but I wanted the player to kind of move with the tiles. But when I implemented this, I realized that even though it was realistic-ish, it actually turned out to feel really bad. And I was already cutting corners implementing all of this, and so to fix this, I had to cut a whole lot of corners. Now my code was really going to dust. Other than that, another notable thing to mention is that I actually created a vector.java class, which I'm sure there are some of these that already exist, but to help me out, this is what I made. I made multiple different definitions to where I can have 2D chords, 3D chords, and even 4D chords whenever I try to implement a 4D matrix, which ended up not being necessary, although it probably would have sped up my code. And you can see that there is some of the remnants of what I was going to make with the cross vector and dot product. But I never got to implementing those because I removed the 4D matrices. I also removed some other classes that I just didn't have a use for anymore because the code was getting pretty chaotic. Disappointingly, I didn't actually fix many of the corners that I had cut, so that would be staying in for future me to deal with. The next really cool thing that I actually did was add a player animation. Now if you go into player.java, it should just be a cube, but you can see it's 100 lines long. That is because if you go up here, you can see that we add a arm. So we have a left arm and a right arm, and I wanted to add animations for all of them. So the first two animations that I added was an idle animation where the arms go up and down, and then the second animation that I added was a jump animation, which worked a little weirdly, but the fact that it was there was probably good for the game, so I kept it the way it was, where the arms would go down whenever the player jumped and then up whenever the player was falling, kind of like a roller coaster. With a player animation, the next thing to do is work on the actual game. I made the tiles slowly disappear, change color. I messed with that a lot, and I also tried to make the game infinite. There were a couple of ways where I was going to do that, but cutting corners really hurt the ease at which I could get this working, so it took me a while before I could actually get the game going infinite. I added respawn. Basically, whenever the player got below a certain point, I would just reset the entire game. And so there was kind of a game to play. I had to fix the player animation, which I would have to do multiple times because it ended up being really buggy. I believe this time is whenever I added the running animation where the arms move forward and backwards. I also explored with the infiniteness of the game, and there were a couple of ways where I could actually make it infinite. For the game to truly feel infinite, I would need the player to not see where the tiles spawn. Luckily, I had implemented a fog system, which we can go to pixel.java and see that we have all of these amazing functions with the blend, the compare. And so basically, by taking the background color and for every pixel rendered to the screen, I would take its distance, and based on how far away it was from the player, I would merge it with the alpha value with the background color, and that would make it appear to be a fogness. And with some confusing math, which shouldn't have been confusing, but I cut so many corners that it was confusing, I was able to finally get it to where it was adding tiles behind this little fog area that's around the player, and then the tiles would move in. And even if somehow the lag is so bad, which by the way, I was implementing lag protection to this entire game, it would still render tiles. And in this process, there's a little timer here as the tiles behind you slowly fade away. Now that's not the real way that you're gonna die, but it's gonna make sure that you don't just idle and like wait the entire game. And so I could finally actually implement the progression of the game. And so I wanted to add levels, and that's exactly what I did. I made it to where whenever you go forward, you basically set a spawn point. That way if you go backwards, you don't get progression for going forwards until you pass that spot. But as you move forward, you would get a progress bar that would slowly fill up. And once it reached the end of the progress bar, you would go up a level. And whenever you go up a level, not only do you go faster, not only do the tiles disappear faster, which by the way, your animations will speed up as you move faster, but also the tiles will start to become more and more rare, making this game really difficult. Also, the levels become longer and longer. So at first, level 1 is really short, but eventually it gets really long. The system in which I implemented this was actually really cool, and I'm really proud of it. The progress bar is smooth, and I also added a animation every time you got to a new level. There isn't a respawn animation, sadly, but the game is actually complete. Now, I just want to play with y'all real quick and show you all the features that it has. If you're wondering where the class files are, I actually wanted to hide the class files, and I'm really proud of myself using settings.json to hide the class files because they're kind of annoying, but I do have all the class files. Everything is in fact properly compiled. Well, I'm not going to include this in the video, but I actually made a mistake trying to use Java on render.java. All I need to do is Java render, and we have the game booting up. You see, we're on level 1. I gotta get moving. So here we go. We got the animations for the arm. We jump. We can see we're progressing in the levels. I know this is a lot to take in. We got the shadow, which I don't believe I mentioned this, but I did implement a shadow. It's actually just a square that stays at the same Y value. And it's black, matching the background. It doesn't actually disappear whenever you get off the background. You can see I just fell off into one of the gaps. You'll notice a really cool thing that I implemented, basically to prevent me from implementing horizontal collision, is that whenever you start falling, it'll stop you from moving. So like, I can't turn whenever I fall off of the map. And of course, it checks to make sure you're at the proper Y value, and then it'll stop all of your movement. We have a little idle animation, if you haven't noticed that yet. And let's actually see how far we can get. You also notice that this game is running at full screen. FPS is hovering around 30, 40, even getting up to 60 at some points. And honestly, this game is really fun. I'm not sure if there's anything like it. I died at around level 6, but it was pretty fun. I will show you a little gimmick, is that you'll see that the tiles only start to disappear once they're rendered, which makes for a weird game mechanic. which is fine because the tiles are disappearing only once you've rendered them, so it's not like an issue. But I really wanted it to be like gradual like this, but once you get to a point it will like not be gradual. But once again, that's fine. It makes it to where even if the tiles are disappearing really quickly, you can still progress in the game. And we are on level 7. This is the highest that I've ever gotten to. So that is the game. I had spent so long working on this project. I think it took me about a month to make. And the amount of stuff that I learned about 3D rendering is honestly incredible. And if you like this video, hit the like button. Subscribe, because we were trying to reach 100 subscribers before I solved 100 LeetCode problems. This originated whenever I made this video, most LeetCode problems in 1 hour, where I did 20 LeetCode problems. They were really easy, but I did 20 LeetCode problems in 1 hour. If I go to my LeetCode account, you'll never guess this. I haven't been doing much LeetCode as of recent because I've been working on this project, but sometime in the middle of the project, I broke 100. We're actually at 114 LeetCode problems solved, ranked almost sub 1 million. Like, I mean, it ain't bad. You can see that, like, whenever I put the grind in, you know, I was just getting some LeetCode stuff done. But that challenge, I don't know what to say. Y'all failed. But I'll give y'all some redemption, which I really think we can do if I keep, like, pumping out videos. 200 before I solve 200, because there are no more easy problems, like really easy gimmicky ones like you would see if you watch this video right here. So y'all do have a chance, and I believe in y'all this time. So like, subscribe, drop a comment what y'all want me to do next. Watch my other videos. I mean, we have a decent catalog out now. I will say that if you were to go rewatch this one, I should have warned you. I did not know what I was talking about in this video. I knew like a little bit, and I mean I wrote the program, but I learned so much more, and in this video I feel like I progressed a lot. But yeah, I'll see y'all in the next one.